This video is on the Arrhenius theory of acids and bases. This is one of 3 acid-base definitions. So just in general, acids are substances that have a pH that's less than 7. They will change blue litmus paper to red, or if you put red litmus paper in them, they will stay red. So this is an indicator to tell if something's an acid or a base. And they tend to have a sour taste. So these are things like vinegar or lemon juice. Bases have a bitter taste and a very soapy feel. Or they feel like soap. So like soap is a base and it's very slippery. They turn red litmus paper blue, or they would take blue litmus paper and it would stay blue. And their pH is greater than 7. So less than 7 is an acid, greater than 7 is a base. Anything that is right at 7 would be neutral. So the definition for an Arrhenius acid is anything that will produce hydrogen ions in water. So hydrogen ions are going to be your H+ ions. Bases are going to be products that things that release hydroxide ions. So anything that has an OH-. So this definition is pretty narrow in scope. It limits us to just aqueous solutions, first of all, and then it doesn't include a lot of things. Like, for example, if you remember back when we did our electrolyte unit, we learned that ammonia, so NH3, was a base. But that would not fit this definition because this in water would not produce hydroxide. It doesn't even have oxygen in it. So it is a base, but it doesn't fit this definition of a base. So it's a bit limiting. So when you have nonmetal oxides and you put them in water, so think about what this means, a nonmetal oxide. So some nonmetal that is bonded with oxygen, and you put it in water, it will form an acid. So an example would be like NO2, for example. So let's say we had NO2, and we reacted it with water, right? Put it in water. What we would get would be HNO3, which is nitric acid. And then we would need to balance this, though. 2. Okay, so that's what nonmetal oxides will do. So basically, they're all of those pieces are going to combine. So if you remember, this will be a synthesis reaction. Another synthesis reaction, though, that's slightly different would be if you have a metal oxide in water. So a metal oxide like lithium oxide or barium oxide will make you'll get hydroxide ions. So what will happen here is they will also combine, but you will get something like this. Like if we had barium oxide, BaO, and water, we'd get barium, but we made hydroxide. And barium is +2, hydroxide's -1, so we'd have 2 of these here. All right, so let's look at a couple reactions. So this first one, Na2O plus H2O. So Na2O, we've got a metal oxide. Sodium's a metal. So what we're going to get here is it's going to make a hydroxide. So we're going to get sodium as our cation and hydroxide as our anion. And it's a +1 and a -1. So here's our formula. And then we need to put a 2 here to balance it. In the second one here, we've got SO2 and water. And SO2 would be a nonmetal oxide. So what we're going to make here is our acid. So we're going to get hydrogen, and then all the other pieces will combine. So hydrogen's a +1 charge, and everything else is going to be S with 3 O's. And S with 3 O's is sulfite, right? SO3 with a -2 charge, which means you would need two hydrogens to balance that. All right, so related to all this, to help prep us for what's coming up, is if you remember when we did electrolytes, we talked about strong acids and strong bases versus weak acids and weak bases. We're going to talk about that more and kind of what that means. But if you remember, strong acids, so strong acids and bases, will dissociate 100%. So remember, they'll dissociate completely. So we need to make sure we still know these. So make sure, if you need to go back and look them over, that you know the strong acids and the strong bases. All right, there's that list, there's that Quizlet. So any acid that you know it's an acid, but it's not on the strong acid list would end up being a weak acid. Same with bases. All right, so quick overview. Arrhenius acids and bases are Arrhenius acids produce hydrogen ions, and Arrhenius bases produce hydroxide ions.